Okay, it's lesson 10, last week of summer, and I hope you guys have gotten a little something out of this math program this summer, and I thank you for trusting me to give you a good look at what's to come, and I hope it hadn't been too painful, okay? So lesson 10, I really cheesed out on you. We're talking about polygons, okay? And this is the word, this is the title really of the unit, is polygons. And poly it just means many, FYI, and a gon just kind of has to do with number of sides. So it's just saying many-sided shapes or different-sided shapes. And this is a chart. You probably know some of these. I mean, you know 3 sides is a triangle, 4 sides. You may have just called a 4-sided thing a square or something, but it's technically a quadrilateral, a pentagon, hexagon, heptagon, octagon. I didn't even know 11. I'm not going to lie, till I just saw it. I don't know it, but that's not one that I've memorized. But anyway, these are some popular names of those types of shapes. Now, what we're going to do in this video is talk about sort of the difference between a regular and an irregular polygon, and then what's true about all the angles, okay? Because there's like all these different things that you can do as long as it's a regular polygon. Now, a regular polygon and an irregular polygon, very different. So let me see if I can explain the difference here. Okay, I'm just going to do it with a 4-sided shape real quick. Oops, that was not good. Okay, a regular polygon is one in which all the sides are congruent and the angles are congruent. An irregular polygon would mean, like, see how many sides this has? This has 1, 2, 3, 4 sides, okay? So it would be a 4-sided shape, but maybe they weren't all the same. So like an irregular polygon might look like 1, 2, 3, 4, something like that, okay? Where maybe 2 of the sides match, but for sure all 4 of them do not match. And look at all the angles. All the angles look like totally different, okay? So that's the difference between regular and irregular. So what we're going to focus on is mostly regular polygons today. So the truths about interior angles, I want to focus on a regular polygon, okay? And I want us to think about, you know, what that would mean. And the main thing is for you to note that these have congruent sides, and also congruent angles. And that's going to make it possible to sort of find out a lot about the shape, because no matter how big it is, as long as these two things are possible, there's all these different cool correlations. So let me show you what I'm talking about. Let's draw 3 basic shapes, okay? A triangle, a square, and let me do a 5-sided. So I need to somehow do a pentagon, but everybody needs to kind of be the same. Ooh, I think I did it. Okay, so on our pentagon, these are all the same side length and they're all the same angle, and same thing with these two. So what ends up happening here is this is 3 shapes that look regular. They're for sure regular, you know, if they're marked. So if all of these are marked with the same thing, then you know it's regular. And you can start to make predictions about the interior angles. Like, for instance, on a triangle, if I said, okay, what do the angles of a triangle add up to? By now, you guys know that's 180. But some people don't know on a square what that adds up to. So what people in the geometry world do is they ask themselves, how many triangles is the least amount of triangles to cut this into so that I can figure out the answer? Well, if you notice, if you just draw a diagonal right here, I've cut this into 2 triangles. That one has to add up to 180, and that one has to add up to 180, right? Okay. If it's a 5-sided figure, take a look at this picture. What's the fewest number of triangles that you could draw and still have the shape? Well, let's say I start here. You would probably have to draw one there, okay? But now that's not a triangle, so then you might have to draw one like right there, okay? So if I have 5 sides, I can draw it as 3 triangles. If I have 4 sides, I can draw it in 2 triangles. And if I have 3 sides, I draw it in 1. So if you've noticed the difference between those numbers, 1 triangle for 3 sides, 2 triangles for 4, and 3 triangles for 5, there's always a difference in 2. A difference of 2 between the number of sides something has and how many triangles you can draw inside of it, okay? And because of that, there's a formula for how to find the sum of the interior angles, okay? And what that formula is that you take the number of sides, so n is number of sides, okay? The number of sides, and you subtract 2, and then you multiply by 180. Now, why do you multiply by 180? Well, because there's 180 degrees in each of those triangles. So it's like this part of the formula is telling you, hey, here's how many triangles you can make. Now multiply that by 180 so that we know how many angles are in our shape. Okay? So what we could do with this is, if you have a calculator, you could come back up here on your table, and I think you need to add a column and put interior angle measure. Okay? And the interior angle measure, and actually we should put interior sum of angle measures, okay? And what we would do is just run this formula over and over again. Remember that formula from below? It's n minus 2 and then times 180. So for a triangle, 3 minus 2 is 1. 1 times 180 is 180. But we already knew that. A triangle has 180 degrees inside of it. A quadrilateral, 4 minus 2 is 2. 2 times 180 is 360. Same thing, we already knew that because we drew it below. But for a pentagon, n minus 2, so 5 minus 2 is 3. 3 times 180 would be something. What would that be? 3 times 180, I need to add another 180. Is that 540? 180, yeah, 540, so 540 degrees. Then you would keep running that formula over and over, and if y'all want, take the time to actually write how much it is for each shape, okay? You don't have to, but this may be a shortcut to help you out later if you'd rather just memorize those than keep doing the formula over and over and over. But that's all you're doing is just, you know, this minus 2 is 4, 4 times 180. So that's going to be 720. Let me add another 180 just because it's easy right here on this one. 7 minus 2 is 5. 5 times 180 should be 900. Okay, I'm going to stop there, but you could keep going if you want. Now, what if you don't want to know the sum of the shape? Okay, what if you don't want to know, okay, well, all these angles add up to 180. What if you just want to know about one of them? Like, for instance, let's say you have that pentagon again, and you know it's a regular pentagon, and somebody says, hey, what's this angle right here? Okay, well, first of all, this angle right here is the same as all the others, so the idea would be to take the total number of all the interior angles and then divide by however many angles there are. So there's 1, 2, 3, 4, 5. So if I did this formula from over here, n minus 2 times 180, this gives me the total of all of them. But then if I divide by, in this case, 5, I'm dividing by the number of sides. And this would be the magical formula that would tell you each interior angle. So for this problem, we'd be plugging in the 5, so it would be 3 times 180 over 5 sides, or 5 angles, and whenever you math that out, I think that was 540 divided by 5, so I think it's 108 degrees. So you could do it like that, okay? So if you want, that's what most of the practice is. It's either going to ask you for the sum of all the angles, or it's going to let you go ahead and divide it out to get each interior angle. But these are your two main formulas that you can use. And you can either run the formula every time, or you can do that chart at the top and use that to help you make it faster. Okay? All right, now, what about finding area? There's a special formula for finding area, but it's only if it's a regular polygon. So sides and angles have to match. But if it is, it's a pretty cool formula, and it makes life really, really easy. The area is 1/2 of the, I'm going to write P times A. P stands for perimeter. Oh, I can't spell. P equals perimeter. Okay. And the A stands for something called an apothem, okay? You've probably never in your life heard of an apothem. Most people don't know what that is. So I'm going to show you on a picture, and then we'll run the formula, and I think you'll think it's pretty dang easy, okay? An apothem is kind of like a radius. It really is. It's kind of like a radius for a shape that's given. So if it was something like, let me draw a 6-sided one, just for funsies. Okay, a 6-sided one's called a hexagon, right? And an apothem would be like the radius of the shape. And here's the deal, though. It's not drawn from the middle to a corner or a vertex. You don't draw it to a vertex. You just draw it straight down so that it's perpendicular to the bottom. Okay, you want to create that 90-degree angle right there. So this right here is an apothem. Now an apothem can be drawn in several spots, right? Because I could draw it here, or here, or here, or here, or here, or here. So there's always a bunch of apothems on a shape, but as long as you know what that is, like let's pretend that's 6, and then let's pretend that somebody gave us that this is 11. Okay, then we could totally figure out the area of this shape by doing this formula. Okay, so if I want the area, I need to do 1/2 of the perimeter times the apothem. Okay, and I just did parentheses here because I have to think about it, right? All right, perimeter is just adding up all the way around. So if this is 11, then that's 11, that's 11. Everybody's 11, right? So what's 11 times 6? 66. Okay. So add them up all the way around, and then times the apothem, which on this one is labeled with a 6. Oh my gosh, this is so evil. I didn't mean to do that. Everybody say a quick prayer and then come back to this problem. Okay, let me cut this in half, 33. So 1/2 of 66 is 33, and then I'm multiplying that by 6, so I'm going to get, not 99, I don't know where I got that from. I'm going to get... That's an 8. That's to carry the 1. 18, 198. Okay, 198 would be the area of this hexagon. Okay, so hopefully that's enough to get you started on the assignment. And, you know, if you can get it through at least halfway, then you know what's up. And if not, watch the solution video, and maybe me doing a problem will inspire you to do others and give you some hints on how to do others. Okay, so good luck, people. We will see you on solutions.